Hi everybody. So now that we've shown you the formulas to compute permutations and combinations, we want to do a few more examples here on our notes. So let's go back to talking about pizzas, number 5 here. So how many 3-topping pizzas are possible if a pizza shop has 9 different toppings? Well, you're simple. You're just choosing 3 of 9, and we don't really care about the order, right? So the answer would be 9C3, right? Okay, and that turns out to be 84. Now, what about the number of, how many possible pizzas are there with at most 3 toppings? Well, we want to first find the number of 0-topping pizzas, 1-topping pizzas, 2-topping pizzas, and 3-topping pizzas. And then what we're going to do is we're going to add all these numbers together. Okay, well, 0 top, there's only 1, okay, which would actually be the same as 1, or you can think of that as 9 choose 0. 1 topping, there would be 9 toppings, so this would be 9. Okay, which would be 9, which is the same thing as 9C1. How many 2-topping pizzas? This would be 9C2, and we already know that there are 9C3 ways, 3-topping pizzas. So if we add all these together, this is 1 plus 9 plus 36 plus 84, and this adds up to 130. All right, and we are adding, not multiplying, because these are all separate cases, right? Okay. Next, on number 6, we have a jar with 5 red balls and 6 green balls, and we choose 3 balls from the jar. How many 3-ball combinations are possible? Combinations means we use the order doesn't matter. So, and we have a total of 11 balls total. Okay, so there are 11 balls total. We choose 3. So the answer would be 11C3. Okay, which is 165. All right, now what we want to do, based on that information, we want to find what's the probability that all 3 are red. Now the way we can do this is we can think of it this way. Here's our 5 red balls, and then here are our 6 green balls. Okay, if I were to ask you, give me 3 red balls, you would choose 3 balls from this set of 5, right? So it makes sense that there are 5 C3 ways you can get all red balls, right? So those are the number of outcomes in which we will get all 3 red balls, and the total number of outcomes again is 11C3. Okay, so the probability, so this is 165, this is the size of our sample space. So the answer would be, we have that this turns out to be 10, so this would be 10 over 165. All right, let's skip down here and talk about how many ways can we get, what's the probability of getting 2 red and 1 green. Okay, so if I asked you, okay, I need 2 red and 1 green, well, what do? You pick 2 red from here and pick 1 green from here. 2 from here, and then 1 from here. So we're actually doing like 2 subtasks, right? There are 5 choose 2 ways to pick 2 red balls, and there are 6 choose 1 ways to pick the green ball. So the number of ways this could happen would be 5C2, and then multiplied by 6C1. So this represents the number of ways we can get the number of outcomes in which this happens, and then we divide by the total number of outcomes, 11C3. Okay, and then this turns out to be, this is 10 times 6 over 165 or 60 over 165. All right, what's the probability of 1 red and 2 green? Well, so if I ask you to find a combination like this, you would pick 1 ball from here and 2 from here. So there are 5 choose 1 ways to pick the red ball and 6 choose 2 ways to pick the green ball. And then we divide by the size of the sample space again. So this is 5 times 15 over 165, or 75 over 165. Okay. And then finally, what would be the probability of all 3 green? Well, you just, if I asked you that, you'd pick all 3 balls from this set of 6. So this would be 6C3 divided by 11C3. Okay, that 6C3 is 20. So this would be 20 over 165. Okay, you can take out your calculators and actually, find out what these are in decimals, but you don't have to. We won't go much further in terms of simplifying. Okay, now in our next example, let's things change a little bit. Let's add some white balls to this situation. So now we have 2 red, 5 green, and 3 whites. So we're in this situation. There are 10 altogether. We're choosing 4 balls, so we know that there are 10C4 possible outcomes. Okay. In this case, let's find the probability of all green. Well, if I asked you something, I want them all green, you'd pick 4 from here. So this would just be 5C4 divided by the size of the sample space, 10C4. Okay. And this turns out to be 5. By the way, this turns out this is 5 over 210. This turns out to be 210. All right. Let's say all green or all red. Okay. So basically, we want a problem of all non-white. Okay. So one way to look at this is they have, instead of this situation, let's say there are 3 white and 7 not white. Okay. So if I want one of these combinations where all green or all red, you're getting your balls from here. So the number of ways this can happen, it would be 7 choose 4. So the answer would be 7 choose 4 divided by 10 choose 4. Okay. And this turns out to be 35 over 210. Okay. If we wanted to find the probability of 1 red, 2 green, and 1 white, well, we're in this situation. I said I tell you I need 1 red, 2 green, and 1 white. What do? You pick 1 from here, 2 from here, and then 1 from here. So there would be, we're talking about 2 choose 1 times 5 choose 2 times 3 choose 1, all divided by 10 choose 4. Okay, we're multiplying these because this was a process of finding that combination. Okay, so I think when we compute this out, this is 2 times 10 times 3. So this is actually 60 over 210. Okay. All right. Now let's for the last example, we'll go back to our cards. Okay, before the days of Hold'em, everyone played, a poker with 5 cards in their hand. So let's go talk about that. 5-card hands dealt from a standard 52 card deck. We don't really care about the order in which the cards are dealt, right? So we're again working with combinations. So how many hands are possible? Well, it would be 52, choose 5. Okay. And this turns out to be, let's see, I wrote it down somewhere. Yeah, 2 million, it's, 2,598,000. And then 960, I think. Okay, and double check this on your calculator. To say, we don't want to keep writing this number over and over again, so in these problems I'm just going to leave it as 52C5, and then you can compute this on your calculator. Okay, so if we wanted to find what's the probability of getting all clubs, okay, well, it's kind of similar here. If I asked you, I want, give me a hand with all clubs, you first pick your club. You have to pick your clubs, right? And there are 13 clubs to choose from, right? Okay, and so there would be, pick 5 of those, so you'd have 13C5 divided by the size of our sample space, which is 52C5. So that would be the probability of all clubs. If we wanted to compute the probability of 2 clubs and 3 diamonds, okay, I'd say if I asked you to come up with a hand with 2 clubs and 3 diamonds, first you would pick your clubs, then you would pick the diamonds. So basically, to find the clubs, there would be 13 clubs, you choose 2 of them, and then there are 13 diamonds, and then you choose 3 of those. Okay, and there's your 5-card hand, and then we divide this by the size of the sample space again. So that's that probability. The probability of exactly 3 kings, okay, the way we can think about this is a deck can be separated into kings and non-kings. That we know that there are 4 kings in a deck, and then 48 non-kings. So if I asked you to come up with a hand with exactly 3 kings, you pick 3 from here, and then 2 from here. So there would be 4C3 ways to pick your 3 kings, and then 48C2 to pick your 2 non-kings, and then this is all divided by 52C5. And then finally, what's the probability of dealt 4 of a kind? So that means you have 4 of one denomination, like in this case all 5s, and then some other card which is not a 5. Okay. Well, there are only 13 possible 4s of a kind, right? You got 4 aces, 4 2s, 4 3s, all the way up to 4 kings, right? So there are 13 4 of a kind, so there would be 13 possible denominations, so you choose 1. And then there are 48 cards, which are, in this case, there would be 48 cards that are not a 5, so you pick one of those. So it's 48C1, and this is 52C5 again. So this is the number of 4 of a kinds you can get, and again, this is the total number of outcomes, right? And it might be interesting when you compute this to see actually what the probability is. I played way too much poker in my times, and I was online for a long time, and I played online, and I had my share of 4s of a kind. So didn't get much money for them, by the way, but that was the nature of the game. So that is all I have. There's a lot more stuff in this chapter. Please do your homework or problems and get lots of practice, and I will see you next time. Bye.